So hello again, my name is Marika and I will be the moderator of today's event. So I know that not everyone has joined yet, but we will start and talk about our company and wait for everyone. So we are welcoming you to our dynamic talk by Grid Dynamics. It's a very Spring Fest. It will be 2-day event. So today and tomorrow, you will hear technical topics from our engineers. And we are ready to start and tell you more about our company. Grid Dynamics is a leading provider of technology consulting, engineering, and data science services for Fortune 1000 corporations from financial, technological, and retail sectors. It has been operating since 2006 in headquarters in California and has development centers in the United States, Eastern and Central Europe. As for today, Grid Dynamics brings together more than 4,000 engineers in 13 countries all over the world and continues to grow steadily. Grid Dynamics is a NASDAQ-listed public technology service company with core expertise in big data, data science, machine learning, i.e. scalable omnichannel services, DevOps, and cloud enablement. Here you can see some of our clients in different sectors. There are a lot of well-known companies that we are working with. And if you want to know more about our company or join us, please find more details on our career website. You can scan QR code now or share the link after our career with dynamics.com. Also, if you are interested right now, you can send your CV on email that you can see at the slide. So also before we start, I wanted to tell you some rules about our event. We will have a tech talk from our speaker. I will present him in 1 minute, and you can ask the questions in the chat in the middle or while he will talk. So just please check that a message will be seen for everyone because you can control it in Zoom. And also in the end of the event, you can unmute and ask your questions by mic, but please check the microphone is muted while we have this technical talk because it's very important not to distract our speaker. So for today, you will listening the topic of covering all the bases, comprehensive web application testing, and our speaker, Alexandr Grisin, our QA engineer, will be here for you. So Alexandr, are you ready? So I can share your virtual mic to you.
Hello, everyone. Today we're going to look at the web application testing from different angles. And let me introduce myself. My name is Alexandr Grisin, and I'm a quality assurance engineer with over 10 years of experience. And for the past 4 years, I'm working for the Grid Dynamics company. During my career, I have been involved in different stages of product development, mainly e-commerce, from providing an initial overview and consulting services to testing the front-end and back-end components of an application. I had a lot of doubts about delivering this speech. On paper, it basically covers the foundational level of ISTQB. We all know about the testing pyramid and various testing types. We all went through these topics during the job interviews, either as an interviewer or interviewee. But what I actually want to talk about today is how we can apply testing pyramid model to a model development and QA role on all of its layers. I will aim to provide a practical overview of how you can enhance the quality of web application through effectively applying common testing practices. As we delve deeper into the testing phase, we will be constructing our testing pyramid using a single technology stack, which can be applied across the application's various components. We will talk why this is important, review the tool set, and we will take a fresh new look at the existing tools to enhance the process. QA implication on all phases can not only increase the quality of the product, but also build strong collaboration within the whole development team. We all know about the shift left approach. It is a practice of moving testing, quality, performance evaluation early in the development process. So why don't we shift ourselves left as well? As a reference, we will be using generic web application, which utilizes React for the front end and Node.js Express for the backend. With this example, I will be able to provide a relatable context by demonstrating how the principles and practices can be implemented in the real-world scenarios. So let's start. What is a testing pyramid? It is a model or a framework that helps development team to create a high-quality software. And what does it consist of? Tests, of course, tests. But what kind of tests? Unit, automation, manual, UI. All of these answers are probably correct. It is not important what you call it, but what it does. So you see a pyramid on the screen. Do you think it is correct? Probably not. But why? What's wrong with it? Or what could go wrong with it? Can you give me your answers in the chat, please? Yeah, you're right. Yeah, it's upside down. It means it can easily fall and break. And we're probably not going to make it to the British Museum because they don't need broken artifacts. So see a few other answers that are correct. All of these are good, thanks. So let's move forward. Does this look any better? Yeah, I think yes. Now it has a white base and makes it more stable and reliable. Why we need to follow testing pyramid model? To successfully release application out into the world, it needs to go through tests. And the testing pyramid is helpful for some reasons. It provides a logical and iterative framework for prioritizing which types of testing to concentrate on and when. The pyramid structure is also logical when you consider the number of tests that you will need within each stage of the pyramid. Testing pyramid also facilitates faster feedback on the performance of the application by considering tests that needs to be conducted on both early and later stages of the software development. With a built-in reminder to get feedback as early as unit test level, teams can both find and resolve bugs more quickly. Testing pyramid also offers an excellent approach for development team to enhance its agility by simplifying the testing process and enabling faster and more efficient delivery of projects. Essentially, our goal with testing pyramid is to increase delivery process speed and reduce its cost. Unit tests are fast and cheap, making them a valuable tool for identifying bugs and issues early in the development cycle. End-to-end tests, due to its comprehensive nature, take longer to execute and therefore tend to be more expensive. However, they are still necessary to ensure complete test coverage and focus on the end user behavior. What are we going to focus on when building the testing pyramid? Bottom to top. As obvious as it sounds, it is a very important principle to follow. SQA, sometimes we can just sit and relax and wait for the story to be ready to start testing. It means that we have already fallen behind on the whole delivery process. We missed the development context. We missed the low-level test coverage. Honestly, I've been there. Well, it's hard to catch up and get back on track. QA role should start before the development begins. Tests should come first. Technology stack. This is another thing to consider. By building our testing pyramid using a single technology stack, we can create a more efficient and streamlined testing process. The approach allows us to leverage the capabilities of a specific technology stack to carry out tests across all layers of the application. It also improves team collaboration. Essentially, we're all talking the same language when all parts of the development toolkit is single stack. We want our application to be functional and accessible, which means functional, non-functional, and visual aspects are all equally important. We will be constructing our testing pyramid, focusing on each of these aspects on each layer and across application various components. You may have heard a joke about QA walks into a bar and orders a beer, two beers, 0 beers, -1 beer, etc. And then first real customer walks in the bar and asks to use a bathroom, and then bar suddenly explodes. Yeah, it's funny, but it's also a good demonstration of a tunnel vision because of not properly applying testing pyramid model. All the number of beer test cases can live on the broad unit testing level. Beer is just a component in the bar application. Covering these units is your base. Once we're done with the components, then we can focus on the end user behavior on some later testing stages. So let's start with the base of our pyramid, the unit test. We want to be confident about the quality of our building blocks. As a QA team, we often overlook the importance of the unit testing and delegate it solely to the developers. I would like to talk about the significance of expanding QA team role in this phase and highlight the need for collaborative effort to ensure product quality. Unit testing is a perfect place to test critical usability and quality issues like keyboard behavior, accessibility, error states, and edge cases. Moreover, when component is completed, those tests will permanently add value as complete document of the component's functionality and states, as well as a set of precise regression tests for anybody else working on the same component in the future. Let's see how QA can contribute into the unit testing and leverage skills, mindset, and existing tools to enhance the process. Unit testing involves individual components of an application to ensure that each element performs the expected actions. So let's take a look what are the tools that can help functionally test our components. Storybook. It is a front-end tool used to build UI components in isolation, which has over 19 million monthly installs. It's pretty popular. And it's commonly used in front-end development. It primarily focuses on decoupling the application component from business logic. It also decouples from the interactive state and application content. So you can show and test components in full isolation. Jest. It is another popular, easy to install JavaScript testing framework. By the way, it is maintained by Meta. Testing library is another widely used JavaScript testing framework. And Cypress is a very popular end-to-end testing framework that it also provides a great workbench for building unit tests. While there are other numerous tools available on the market, this discussion will primarily focus on reusing tools that are already present in the project and that are compatible with the technology stack. So let's start with the Storybook. It provides an isolated frame to render components without interference from the business logic. You can render a specific variation of a component by passing in any inputs, mocking data, faking events. This is exactly what we need for the unit testing. Imagine you want to test a header component. It is intended to show a login button for the guest users and a welcome message for an already logged in user. This slide over here shows how we can pass different user states to the header component and assert its behavior. Moreover, Storybook lives in the vast majority of the front-end projects, so you don't even have to bother installing and integrating it. What you will need is to install Storybook Interaction add-on, and you're good to go. Now you can make your stories live by interacting with the components and validating the results. We can also interact with the component. Under the hood, Storybook Interaction add-on mirrors the testing library user events API. That should provide you with all the tools to manipulate your components. On this example over here, we are submitting the form, and asserting the result. We can find any necessary selectors by test ID and action them using standard API like type, click, hover, anything else. With a Storybook add-on called Test Runner, we can run these tests run these stories from the CLI, which means we can easily integrate this test into our continuous integration tools. So what else do we have? Many of you know Cypress as a great end-to-end testing framework. And indeed, it is a great end-to-end testing framework. Cypress is widely used in the industry, and high chances you may already have it on the project. But Cypress is not only built for the end-to-end test, it also provides a component workbench for you to quickly build and test components from multiple front-end UI libraries. Since it is also Cypress, you get same exact APIs, plugins, and ecosystem as you're used to with the end-to-end tool. The only difference is that all the interactions are isolated within the context of a single component. You can run Cypress component test headless from CLI for easy CI integration, or visually to see component in action and interact with it in the test runner for debugging. Let's not only talk about how functional our components are, but also how accessible they are, as it can greatly contribute to the end user experience. Accessibility is the practice of making websites inclusive to all. It means supporting requirements such as keyboard navigation, screen reader support, touch-friendly, usable color contrast, reduced motion, and zoom support. Accessibility tests audit the render DOM against a set of standards based on the Web Content Accessibility Guideline rules and the other accepted best practices. My colleague will tell you a little bit more about accessibility testing tomorrow, so stay tuned. What tools can we use to run the accessibility audit? Our good old friend Storybook. Storybook provides an add-on called A11Y. It's powered by Axe Core, which automatically catches up almost 60% of the accessibility issues, and it comes for free. As we already know, the Storybook can easily manipulate the component states and behavior. Now, with Storybook Accessibility add-on, we can automatically run accessibility audit on all of our component variations. On example over here on the screen, you can see our existing header login story, and on the right, accessibility audit results. You don't need to set up any additional tests for it. And interesting fact, for my pet project, I initialized and installed React application with the Storybook on top of it. It gave me a few demo components like a button, header, and something else. So when I ran Storybook accessibility audit for the first time, I actually received accessibility violation. So nobody is perfect. And by the way, it works well with the Storybook Test Runner add-on that we already use. It performs the accessibility checks, and that allows to gather component accessibility feedback as early as the unit testing from the CI runs. As always, we don't only care about functionality of our component, but also how they look, or rather how customers will see it. I hope you watch The Office. And remember the episode when Pam was offered her boss two identical pictures to choose from. Nowadays, we don't want to trust our eyes. And most importantly, we don't to spend or waste time spotting the differences after changes are done. So we have visual regression tools that do the job for us. They work by taking snapshots of every story and comparing them commit to identify the changes. And jokes aside, but again, our tool of choice here is the Storybook. But this time, it doesn't come alone. There are many tools on the market for the visual testing. Storybook documentation recommends Chromatic. It was created by Storybook maintainers. It is a good tool and does the job. But today, well, our goal is to minimize introduction of the new dependencies to the project. So we may choose Percy instead. Why? Because this is one of the vendor integration that you may already have. Quite a few of our projects use BrowserStack. BrowserStack is one of the leaders for running, automating, testing on massive Selenium grid of desktop browsers and mobile devices. And it has acquired Percy a couple of years ago. Storybook is a fantastic tool for visual testing because every story is essentially a test specification. Powered by Percy, it now provides all necessary tools to interact with and upload snapshots to Percy servers. Great thing about using Storybook is that you don't have to write any new tests. We already have stories that cover all functionality aspects and different component states. Now, Percy automatically picks them up. A new build will be created every time we want to run visual testing in our CI/CD. Here we can see build created in the Percy dashboard. We can see branch name and commit hash in the build, or commit hash of the build. It's marked in blue on the screen. We can also see that build is unreviewed, which means we have discrepancies spotted since the previous run. We open the build and see the red spots. Baseline and current snapshots are not identical. Percy will highlight all the differences. It is now up to you to decide whether the changes are good or not. But what does it mean? The differences may be generated by code changes according to the new requirements, or else unintentionally, which is probably a bug. Now, if you accept the snapshot, it will be treated as a baseline going forward. Else, you can reject it and request the code change to fix it. Talked a lot about the unit testing already. Unit testing has to be done right from the beginning of the development. It has to go hand in hand with the development. We should not forget to focus on all aspects and types of testing. One question we may not have covered is when do we want to run the unit test? And as obvious as it sounds, as often as possible. They are meant to be quick and frequent. Of course, it probably doesn't make too much sense to run tests if no changes are done. But we want to run unit tests every time a new code change is committed. It may be in your CI/CD or using the Git hooks or both. But we want to have unit tests run frequently to gather feedback on the build as quick as possible. Visual testing may be a little bit more expensive than everything else. Using Percy comes with the cost to your project budget. Both Chromatic and Percy provide 5,000 snapshot comparison for free every month. For everything else, you should pay. So be careful on deciding the frequency of visual regression runs to save some costs, but also bring some value. And spoiler alert, there are also free of charge solutions that we will cover a little bit later. Until now, we have covered the very bottom unit testing layer. And before we go to the next stages, let's see if we have any questions. Okay, let's go forward. Now we know that our building blocks, the application components, are fine. So what is next? Let's start putting together the individual parts that we have tested in the unit testing phase. In the integration testing, we combine them in a sophisticated way to form an integrated part of the application. Today, we will mostly focus on testing the UI integrated component. The purpose of integration testing is to combine small modules and validate the behavior to expose issues in the interaction between them. On this picture on the screen, we can clearly see that something is not right. The interaction between these two modules does not look great. It basically demonstrates the importance of the integration test. At this stage, we should understand that we are no longer testing modules in isolation. Now we want to focus on checking data communication amongst the modules. Application components should work well together. Similar to the unit testing, with the integration level, we want to focus on functional as well as the non-functional aspects of the application. But well, before covering the testing types, I would like to start with mocking. Managing integration testing could become complex because of few factors involved in it, like database, platform, environment, etc. And mocking comes for the rescue. It is very important at this level of testing. It helps create a stable development environment and isolate it from flaky third parties, or to simulate APIs that does not exist yet. Another good use case of the mocking server is ability to fully replace a heavy backend. Imagine that for your UI testing, you don't have to start the backend counterpart or a database, and you don't have to insert any test data or clean the database every time you run the test suite. We can do all that by simply using mock server and stubbing all the necessary APIs to get fake data to match our scenarios. For the integration testing of the UI, essentially that is what we need. A functional web page that is not burdened by heavy backend and tons of third-party integration. It will be quick to install build and start web application and integrate it into our CI process. So a few great mocking servers options are Postman. It is a must-have application in the toolkit of every QA and developer. It is a great platform for building and using API, but it also provides utilities for mocking Varmo. It is a Java-based mocking server that does not match our concept of single tech stack, unfortunately. But at the same time, it is an amazing tool and can simulate any API behavior you may need for your application, from simple request handling to complex fault simulating and stateful behavior. And the mocks server. It's a Node.js mocking server that fits our technology stack. Today, we will look at the mock server clause. And by the way, it's mocks in plural because there is another one that's in singular. So mock server is quick to install and run. It provides a binary in an npm package. It is also easy to configure because it supports YAML, JSON, JavaScript configuration files, anything. It's also flexible. It provides an express middleware to be executed when the response is received. So that middleware may be used for several purposes, as persisting data modifications, filtering data, adding common headers to all the routes, login data, everything. But what is a mock? It is basically a custom object that mimics behavior of a real one. It is fake data that we will feed to our application. To achieve that, mock server relies on three concepts for simulating API scenarios. First of them is root. It defines the URL and method of an API resource. Variant. It defines what response to send back. Root can handle multiple variants for each particular scenario. And collections. They define all current roots and variants in the mocked API. You can store many collections and change the whole API behavior by simply changing the current collection. This is a simple example of a mock. Here we define a request URL, a method to match the root. We expect to receive an /API/users get requests and respond with a success variant, which is status code 200 and list of users. For each collection, we can define list of root variants we want to handle. Well, last but not least, we need to make sure we configure our application to use mocking server URL instead of a real one. Just go to your configuration files and update the URLs. Here you can see sample environment configuration file, the real application integration commented out on top, and the mocking server URLs active on the bottom. I would recommend keep separate configuration file that will be used for mocking server URLs. It will be best to use in the CI pipelines. So what do we get with mocking? Now we can control responses of the API. This will improve the development workflow. And we can avoid early dependencies with the team developing the API. It also improves testing of error cases or any other cases that are commonly hard to reproduce with the real API. It is very important to make sure you always keep your mocks up to date. Only in this way you can assure reliability of your test results. Now let's go to the functional aspects of the integration testing. What are the tools that can help us functionally test our application? Playwright. It is easily one of the best end-to-end testing frameworks available on the market. Not explicitly, but we have already used Playwright on our project. Storybook Test Runner is powered by Cypress. It is another amazing testing automation tool. We have already used its component testing features, but primarily it was an end-to-end testing framework. Testcafe, less popular, but fast-growing end-to-end testing framework. It is very versatile and enables cross-browser testing. We talk about the integration level of testing, and I'm showing end-to-end frameworks. What's the catch? It is a fair question to ask, but the reason is simple. They just perfectly fit our needs. Our goal on this level is to verify how components bond with each other, and we can mock everything else. Essentially, we get a full web page with predictable behavior due to mocking, and these end-to-end testing tools can easily deal with it. One of our goals is to minimize dependencies. So let's pick Playwright and Cypress as our integration test framework options. Playwright is a framework that enables the reliable end-to-end testing for modern web application. It was launched in 2020 and within a few years has matured and attracted many users. And which is very important, it is very well documented. Playwright is an open source, but it's also attached to Microsoft. It supports many popular browsers and platforms. It is failure resilient due to auto-wait mechanisms and configurable retry strategies. Other great features are, well, the API mocking, the browser API mocking, network interceptors. So for the integration testing, we want to isolate our application from any flaky third-party integrations. And that we needed to guarantee the reliable results without any false positives or negatives. And that is where API mocking feature will shine bright. We can configure our tool to intercept any third-party requests and mock them as we wish. We may not even need a separate tool for it. Cypress delivers same great utilities and comes hand in hand with Playwright Toolkit. Also fast and reliable, and also allows to easily intercept and mock any APIs. Cypress comes with a desktop application that has powerful features for creating, debugging, and running your tests. By the way, while I was preparing this presentation, Playwright released a new version that also has this desktop application, so they compete. Cypress also comes with its own API for creating custom comments and override existing comments. It helps create clean tests. If own API mocking is not enough, Cypress also has an integration with mock server through plugins. So if you struggle to decide which one to pick, then I guess the rule of thumb here is that you can pick Cypress if you already use Cypress component testing. And you can pick Playwright if unit testing is done with the Storybook. But to be honest, you can't be wrong if you pick any of them. They are both amazing and do the job. For the front-end non-functional testing, there is one tool to rule them all. It's a true Swiss knife for the UI, and it's Google's Lighthouse. Google's Lighthouse is an open source automated tool that analyzes web application and pages and provide valuable information to help improve the quality. It has audits for performance, accessibility, progressive web applications, SEO, and more. And the performance audits that check to ensure that your page is optimized for the users to be able to see and interact with the page content. Best practices highlight the opportunities to improve the overall code health of your application. Accessibility audit highlight opportunities to improve accessibility of your application. As always, we don't want to rely on someone manually running Lighthouse audit from Chrome DevTools. Rather, have a reliable source of frequent Lighthouse audits. Google thought about it and made a feature for CI integration. It is called Lighthouse CI, and it is a set of tools that make continuous running, saving, retrieving, and asserting against the Lighthouse results as early as possible. So you get Lighthouse report alongside every PR. You prevent regression in accessibility, SEO, offline support, and performance best practices by frequently running audit. You can track application performance metrics. Lighthouse CI is another node library that is easy to install and configure. Lighthouse provides a server that saves historical Lighthouse data. It displays trends in a dashboard and offers an in-depth build comparison UI to uncover differences between the builds. These trends can expose over time application degradation or vice versa. They can demonstrate that specific code changes actually improve the performance. And the Lighthouse server can be run in any node environment with persistent disk storage or network access to a database. We do not only want to care about functionality, performance, and accessibility of our application, but also want to ensure that the user interface of the application appears as intended for the end users. We have covered doing visual regression for each component. We are confident that our components looks just fine, but it may not be enough. Components may overlap when integrated, or they may be displayed in the wrong order. So let's put our components together and evaluate the visual appearance of the whole application. Do you remember the dress? Remember we all argued about the color, whether it is blue and black, or was it white and gold? Don't let your eyes fool you. Let the tools handle this visual comparison. And by the way, do you think it was actually blue and black, or was it white and gold? Give me your answers in the chat. Let's see who wins. Let's go forward. Our tools of choice here comes as no surprise. The end-to-end testing frameworks, either it's Playwright or Cypress to create the tests, and Percy for visual snapshot validation. What do we get with Percy? First, you fully delegate your snapshot reference management to Percy. It means that when you push changes to your code base and have Percy generate screenshots, Percy groups screenshots into the snapshot and snapshots into a build. So the new screenshots are compared to baseline screenshots from the previous build. Percy takes a lot of care in automatically selecting the best base build to give you clean, accurate differences. Percy is also designed to keep all the computationally expensive screenshot rendering and visual diffing completely out of your system. But Percy does not fully come for free. So if your application is small enough for you to fit in the free 5,000 snapshot per month, then I recommend using Percy as an all-in-one visual review platform. But Percy is optional at this point. If you do not expect to fit in the free tier and can't afford to spend extra money from the project budget for paid tier, then Playwright and Cypress come for help. Playwright is well-versed and the visual regression feature is built in and do not require you to do any additional installation. Cypress, on the other hand, relies on the snapshot plugin to perform the visual regression, but it's another Node.js library to install, so not a big deal. All the computationally expensive snapshot management and comparison will now fall to your own infrastructure. Either it's Cypress or Playwright, you can perform visual regression free of charge, but eventually you'll be the one to maintain the baseline reference snapshot. With the component testing, we had stories in the storybook fully ready for the visual testing because they already covered component in various states. We haven't had to do anything else. In the integration phase, we should invest a little more into visual tests when it's about the whole application, but not too much. We still can reuse some of our recent development. Our goal is to capture UI on specific functional points, and this is where our Cypress or Playwright functional tests come handy. Basically, we have options how we want to proceed. We can fully reuse our functional tests and do visual snapshots on specific functional points, or we can create specialized visual test suite and we'll reuse the end-to-end testing framework page objects, and actions. Well, in either case, our aim is to increase the tests and methods reusage and to reduce the maintenance cost. So, well, we have covered testing of the individual component. We have integrated them and tested that they talk to each other fine. Now it is time to look at the application as a whole. The cherry on top of the pyramid is the end-to-end testing that ensures system integrity. It is a critical part of software testing that evaluates entire system, including all its components and dependencies from start to finish. End-to-end testing evaluates functionality of a system from an end user perspective. And well, remember the Q and bar joke? We have already done the number of beers edge cases on the lower testing levels. It means that we should not worry about them anymore. End user behavior is our primary focus on the top end-to-end testing level. The customer centricity. And in the most cases, the end user is customer in our application. And we should put our customer first, provide positive experience, customer flow. Our goal here is to improve user experience. We ensure that the software meets expectations of a customer and delivers a seamless flow. We should simulate real-world scenarios to make it more effective in finding defects that can be missed in other testing types. At this point, it is okay to have multiple actions and assertions in your test, so you can test complete application flow. When it comes to end-to-end testing, having long tests is not such a bad thing. Are we building the right product for our customer? Is the question that we want to answer with the end-to-end testing. What are the tools we can use for system testing? Same exact testing frameworks we have covered on the integration level: Playwright, Cypress, or Testcafe. Since our goal is to test entire system integrity, our only exception will be that we are not going to mock backend anymore. However, we still may want to disable or mock the third-party dependencies. They are time-consuming. They can slow down your tests. They are also error-prone and can lead to false positive or negatives. We should only focus on testing what we control. You may be surprised I didn't mention Protractor, and well, the reason is simple. Protractor is deprecated and will reach end of life in summer of 2023. We have already covered how fast and versatile these tools are. Let's see some pros and cons to consider when selecting tool for your project end-to-end needs. So let's start with the Playwright. Playwright has parallelization and sharding that comes out of the box. It supports multiple programming languages. Today we talk about the JavaScript and TypeScript only, but Playwright also supports Python, Java, and C#. Playwright supports all popular browsers, but it uses the Chrome DevTools protocol, and it doesn't support actual Safari. But instead, it's open source version, which is the WebKit. With Cypress, it supports end-to-end and component testing. It's a versatile tool that can be used across different testing levels. You can also extend Cypress functionality with help of many useful official and community plugins. Cypress has limited cross-origin testing. And one of its trade-offs that Cypress is pushing is single origin testing. Each test is bounded to a single superdomain. For example, if your application has external payment provider pages, then you will have bad time. You will have hard time dealing with it. Trust me, I have been there. It was hard. Only in some recent releases, Cypress added ability for the cross-origin navigation in a single test. Cypress also supports Safari browser engine WebKit, otherwise supports all popular browsers. With Testcafe, you can execute tests concurrently to cut the execution time. It also fully enables cross-browser testing. It also officially supports the mobile version of Safari and Google Chrome. It officially supports. The downside, it may seem a little bit slower than the others. Testcafe uses page proxying to execute tests across different browsers, and this technique complicates framework. Testcafe team started to gradually phase reverse proxy out, so it may become faster soon. Yeah, I recently checked the release notes, and they actually did. They have added the native automation feature now, and that supports the Chrome Dev protocol. So it may become faster even sooner than I thought. Well, that's about it for today. Let's recap what did we cover. Not only ancient Egyptians can build the pyramids, can do it now as well. Today we talked what are the layers in the testing pyramid, what types of testing we can do on each level, and what automation tools we can use. New QA role. The implication on each testing phase is important and builds the collaboration in the dev team. It helps eliminate the duplications in the test coverage on each level and increase application time to market. And now we know how can we contribute in the single technology stack. We reviewed some great tools that help properly apply testing on various levels. We also using single technology stack not only in the testing toolkit, but it is also a single stack with the source code. And it helps developers and QA talk the same language. So that's it. Let's do the Q&A. Let's see what we have in the chat. But first, let me see, is it white and gold or blue and black?
Thank you so much for your presentation. Yes, you have some questions in chat, so you can check.
I can see them. I see the blue and black one, but someone said blue and gold.
Yes.
That one was good. Okay, let's see. Yeah, we can use CSS to see the colors. Yeah, I agree. This is color pickers. Yeah, looks like Cypress everywhere. Well, I try to use a single stack, and Cypress is good because it's not only a single stack, but it's also cross-level tool. You can use it for the component and for the end-to-end testing. So it's very versatile. Nothing about the IntelliJ. Well, IntelliJ gives you support for the JavaScript. So, well, you can use IntelliJ IDEA for any framework that I talk about today. Is there a workaround for single domain testing in Cypress? Well, yes, there is now. When you open a page with Cypress, you do cy.visit. But if you want to visit another domain, it's cy.origin. So you can do that, but you may face some other issues. It worked for me well, so you can do it now. Cypress has best community. Okay, yeah, Cypress has best community because it's been very long on the market. So it's one of the first tools that was not Selenium. So yeah, it's a great tool and has great community, a lot of advices, answers to questions that you may have. So yeah, it's great. What would be helpful if my project was Windows application written on Electron? Yeah, I think Electron is also supported, but I may be wrong. So yeah, I may need to revisit this and get back to you. So we may chat offline. What recommendation could you give for the visual testing? Will not it be generator for a lot of false positives? If you do visual testing on the component level, you have all the control you need. Basically, you control the state of the component, you control any actions, so it's fully controlled. You can even add additional mocking in that level of testing. So it will be fully handled. With the integration level, again, since we do mocking, we have predictable behavior of our UI. And the only thing we're actually worried about is the banners, the animation banners. So what we can do, we can add some selectors to the ignored list. So these sections of the screen will be ignored by a visual comparison. Percy has also a lot of configuration for this. So yes, it should be pretty stable. It was not very stable some time ago, but now there are a lot of tools that help you to stabilize that. Okay, I work in Cypress and I'm combining the API and UI testing. Do you have a system to automate a test where application sends a confirmation code to an email and we need to implement that code into the classic registration test? So if I understand correctly, you want to get the email somehow, or am I wrong? If you need to get a code from the email, if yes, there are tools like Mail Catcher, and you can configure your correspondence to go to that mail catcher, and it has an API to get the mail content, and you can get a code from it. But that's a separate tool. I hope I answered your question. Unfortunately, Cypress will not be able to do it because this email will be sent from the server. So you will have to mock it from that end. But if you want to do it like an end-to-end thing, I would suggest not to use the mail provider, but like a mail catcher tool. And then through API, get this code from the text of the email. Yeah, Mailsaurus, I think, does the same thing. Sorry, I haven't heard about this tool, but I guess so. Basically, it's like a fake mail that you have access. So you can point all your correspondence, all your server correspondence to a single place, and then just get emails through the APIs that these tools provide. Thank you.
Yes, I think there's no questions, but so thank you, everyone. Thank you, Alexander, for your presentation. It was really, really interesting. So I wish all the best for everyone and good evening. So bye-bye.
Thank you.
Thank you.
Bye.
Bye.
Thank you very much. Goodbye.